We are now going to consider a special type of Möbius transforms. We have some fixed point set 0, which is interior to the unit circle, and we say that C is the conjugate of this fixed number set 0, and we are considering a Möbius transform that is on the form set minus set 0 over C set minus 1. What we are going to prove is the following claim, that the unit disk in the set plane is mapped onto the unit disk in the W plane by using this Möbius transform. What we have to do then, one way of proving it is doing the following. We prove that the unit circle is mapped onto the unit circle of the W plane. Then we have to ask us the question, is the points interior to the unit disk or unit circle mapped to the points interior, to the set interior to the unit disk in the W plane, or to the set which is exterior to this unit circle. But this question is easy to answer because we know that writing f of set equal to w, we have that f of set 0 by inserting set 0 into this expression. We obtain that f of set 0 is equal to 0. So we know that one of the points in the unit disk is mapped to one point in the unit disk of the W plane. So we only need to prove that the unit circle is mapped onto the unit circle in the W plane. So what are we going to do then? First, we know that any point on the unit circle is given by the fact that the absolute value, or has the property that the absolute value of set is equal to 1. We have that C is equal to the conjugate of C0. We recall this. And now we are going to prove that the absolute value, assuming this, we are going to prove that the absolute value of the nominator is equal to the absolute value of the denominator. That's our strategy. So what we are doing here is to prove that, assuming that set is on the unit circle, then this absolute value is equal to this absolute value. So we have to convince ourselves that these two are equal. What we are doing is just the following. The absolute value of any number is always equal to the conjugate, the absolute value of the conjugate of this number. Moreover, conjugating the difference between 2 points is equal to the difference between the conjugates of these points. And we are now inserting the C value. C is equal to set 0 conjugate. So we are substituting this here. Moreover, we have that the absolute value of set is equal to 1. So we are just multiplying this number with 1, namely absolute value of set. This is just a trick. Multiplying set now with the absolute value of set minus C, we obtain this. And now we are expanding this set multiplied with set conjugate minus set C. And remember that set multiplied with set conjugate is always equal to the absolute value of set square. and still set the absolute value of z is equal to 1. So we are using this here, and well, the absolute value of the negative value of some complex number is always equal to the absolute value of the positive value of this complex number. So then we obtain this. So now we have proven that the numerator is equal to the denominator in the case when the absolute value of z is equal to 1. And therefore we can conclude that the absolute value of w is equal to 1. So we have proven that this is equal to this, and if we have some number divided to the same number, we obtain 1. So what we have proven is that the function f of z, this Möbius transform, maps the unit circle set absolute value of z equal to 1 onto the unit circle absolute value of w equal to 1. And this is what I mentioned, that we have to use this information in order to be sure that it is mapped onto the circle, not exterior to the circle.